my dear students. Today, inshallah, we'll complete our curriculum for this year, Unit 2, Electric Energy and Radioactivity. Lesson 1, Physical Property of the Electric Current. First of all, we have to talk about the importance of the electricity in our daily life. The electricity or the electric current is very important. We can use electricity every day in our life, lighting the houses or factories or even the operation of the machines around us. But how the electricity can be generated and how the electric current is generated. The electric current is generated in the electric power stations that are away from our houses. It's about hundreds or thousands of the kilometers. And what is meant by the electric current and how it generated and how does it reach to our houses? Remember with me the structure of the normal atom. The atom consists of positive protons and neutral neutrons, and the electrons that rotate in the fixed orbits around the nucleus. In the normal atom, we have the attraction force between the nucleus and the electrons. So, the attraction force between the nucleus and the electrons that keep the atom constant. On the other side, in the absence of the attraction force, the electrons become free. So, when the attraction force is absent, so the electrons become free from the revolving around the nucleus. So, in connecting the wire with electric source, the electrons move in wires or conductors, creating electric current due to the potential difference in the circuit. Therefore, we can define the electric current as the flow of the electrons or the electric negative charge in the conducting substance as a metal wire. So, the metal wire play an important role in forming or changing the electrons from rotating around the nucleus to become free to move or flow through the wire. So, this is the formation or how the electric current can be generated into the wires. And the physical property of the electric current are current intensity and potential difference and resistance. So we have three of the concepts of the electric current. We have three of the properties or concept of the electric current. We can summarize the concepts or the properties of the electric current as we have three laws in this lesson, three definitions and three laws that relative to the electric current. Okay, first of all, we have the number one, current intensity. So the first law is about the current intensity. And the second concept is the potential difference V. And the third will be about the resistance R. One more time, the intensity is the quantity of a charge or the amount of charge can be flow through a wire or a cross section of the conductor in a unit of time, 1 second. Second, we have the potential difference V. So the symbol of the potential difference is V. Potential difference equals the work done, or it's a work done to transfer a quantity of a charge, a quantity of a charge. So we have first concept of the current intensity, or the I, it's current of intensity, the quantity of a charge that can transfer through a cross section of conductor. If we have a cross section of conductor, or we have part of wire, so the amount of electrons can enter this part of the wire is the current intensity. One more time. The current intensity is the quantity of a charge can be flow through a cross section of conductor in 1 second. So the passing of the electrons through a cross section or a part of the wire in 1 second is the current intensity. Number 2, we have the potential difference. What is the potential difference? It's the work done to transfer this amount or quantity of a charge through the wire. So the potential difference is the work done to transfer a quantity of a charge from one pole of the conductor to another pole. So if we have two conductors or two wires, when the first is high potential, it transfer or carrying the electrons to another or the lower potential. We have two conductors, the first is higher and the second is lower, so the potential difference will make the electrons or the quantity of charges flow through from the higher to the lower. Number 3, we have the third concept or the third property of the electric current as the resistance. When the electrons or the charges that flow through a conductor face as opposition, face the opposition that make the electrons it's difficult to transfer. So the resistance equals the potential difference divide the intensity, divide the current intensity. So imagine with me, we have a cross section of conductor, or a part of the wire, and the electrons can flow from the first part to the second part, or the first pole to the second pole. So the flowing of the electron through the wire in the unit of time, so its intensity. What is the intensity? It's about the flowing of the electrons, the quantity of electrons in a unit of time. And the potential difference is the work done to transfer the same amount or the quantity of a charge through this wire or between two wires, between two conductors. And when we make a resistance, so the resistance equal the potential difference divide the intensity of the electricity. So we can summarize the three laws or the three definitions in this lesson about these triangles, the two triangles. We have the potential difference equal the work done to transfer a quantity of a charge, and we have the current intensity to transfer the quantity of a charge in the unit of time, second. And finally we have the resistance equal the potential difference divide the intensity. So, as we know, we have the current intensity. the current intensity with the low, I equals, or intensity equals, the quantity of charge Q divide the time. And we have the potential difference equals V equals W divide Q. And finally we have the resistance equal the potential difference divide the intensity. But what about the devices that can measure the three concepts or the three physical properties of the electric current? The current intensity can be measured by a device, ampere, so it's a meter and a unit ampere. Potential difference can be measured by voltmeter and its unit volt, and the resistance by device, ohmmeter, and its unit ohm. And the symbols or the symbols of each of them by the current intensity, capital A, when it connected to a circuit, and the symbol of the potential difference as V or capital V in the circuits, and we have to draw a resistance at this figure if it's variable resistance. So as we said before, the current intensity equals the quantity of a charge, and the quantity of charge unit is coulomb. Divide the time by the second. And the potential difference equals the work done by the joule divide the amount of electricity or the quantity of electricity coulomb. Also, by the potential difference we can, or by the voltmeter, we can measure the potential difference of the circuit and the potential difference of the battery or dry cell. We have comparison between the two cells that can draw and connected to a voltmeter. The first connected with the voltmeter in parallel, so the battery connected with the key, connected with the lamp in series together, and all of the circuit can connect with the voltmeter in parallel. In other way we have, in other circuit, we have the battery and the lamp and the open key connected all together in series, connected in parallel with the voltmeter. When the key is opened, so the voltmeter measures the electromotive force, something of the electromotive force or the voltage of the battery only. Finally, we have the types of the electric resistance. We have two types of the electric resistance, as we say. We have the constant, that symboled by this figure, and variable by the that figure. And the variable resistance or the sliding resistance or rheostat, it's kind of resistance that can change or control the value of the intensity and the potential difference.